Good afternoon, good morning, and good evening, everyone. Welcome to the keynote lecture of the Data Excellence Week 2025, organized by the Chinese University of Hong Kong, CUHK Library. The title of this keynote lecture is Research Data Management at the University of Hamburg, Exploring Open Data and Data Ethics by Dr. Stefan Thiemann from the University of Hamburg in Germany. So my name is Xin Zhang, and I'm the Research Data Librarian here at the CUHK Library. We're very excited to host the Data Excellence Week 2025 at the CUHK Library. This week-long event aims to promote and raise awareness of data sharing, data management, and data reuse principles and practices. So today, we're very delighted to welcome audiences from CUHK, other institutions in Hong Kong, and other parts of the world. Welcome to you all. Before we get started, here are just some quick housekeeping items. This session is being recorded and will be shared on the CUHK Library's YouTube channel later. If you have any questions during the keynote lecture, please type them in the chat box. We will have a Q&A session towards the end, during which you can unmute yourself to ask your questions via audio. Now, without further ado, we are very pleased to have our university librarian, Mr. Benjamin Meunier, to give the opening remarks for this keynote lecture and introduce our speaker. Thank you very much, Ben.
Thank you, Chin. Good afternoon, Mei Ho, to our colleagues in Asia and in Hong Kong, and Guten Morgen and good morning to our colleagues in Europe. Welcome to the keynote lecture of the Data Excellence Week 2025. We're delighted that you can join us at the DEW 2025, organized and hosted by the Chinese University of Hong Kong Library. Here at the CUHK Library, we value and promote the importance of research data, both in its use and management. This year, we're launching the Data Excellence Week, a rebrand from the previous Research Data Management Week, to raise awareness and highlight the significance of data use and management across various disciplines. The week will feature a series of engaging events, including today's keynote, an interactive workshop, faculty panel discussions, and student presentations. From the Data Champions program to the Data Analytics Practice opportunity, we're showcasing our initiatives to promote data management and data reuse at the CUHK campus and beyond. The programs during Data Excellence Week are designed to provide valuable insights and practical skills in research data management, featuring perspectives and efforts from both students and faculty members. Our aim is to foster a culture of data excellence and innovation, encouraging the CUHK community to share, engage with, and utilize research data effectively. Yesterday, we kicked off the Data Excellence Week with a workshop on the effective use of the CUHK Research Data Repository. After today's keynote lecture, there will be other exciting events happening throughout the week. Please visit our website via the QR code on your screen or the URL in the chat box for more information about the Data Excellence Week 2025. We invite you to join us in celebrating Data Excellence Week and to take part in the various events and activities that we've planned, whether you're here on campus or anywhere in the world for many of our hybrid and online events. Together, we can advance the understanding and application of research data, driving data innovation and excellence in our academic community. Now today, it's my great privilege and honor to welcome our distinguished speaker, Dr. Stefan Thiemann from the University of Hamburg in Germany. Dr. Thiemann will speak to us about research data management at the University of Hamburg, exploring open data and data ethics. Dr. Stefan Thiemann is a distinguished expert in the fields of meteorology, computer science, and digital humanities. He studied meteorology and physics of the atmosphere and computer science and earned his PhD at the University of Hamburg in 1996. Dr. Thiemann's career spans over 3 decades, beginning as a researcher at the Max Planck Institute for Meteorology and the University of Hamburg from 1990 to 2000. From 2000 to 2017, Dr. Thiemann served as a researcher in the Faculty of Humanities, where he was responsible for IT and digital humanities, and he held the position of Faculty Information Officer. He was also a member of the Chief Information Officer, or CIO, Board of the university. Since 2016, he has been the open access representative of the university, and in 2017, he founded and became the head of the Center for Sustainable Research Data Management at the University of Hamburg. Dr. Thiemann is actively involved in academic committees relating to digitization, sustainable development, research infrastructure, and he represents the University of Hamburg in the German National Research Data Infrastructure Association. He is also a member of the Ethics Working Group in the Center for the Studies of Manuscript Cultures since 2020. Without further ado, let us welcome Dr. Stefan Thiemann. Dr. Thiemann, please.
Yeah, thank you very much, Benjamin. I will try to share my screen and my slide. Maybe you can give me a sign if you can see my
clear.
presentation mode. Okay, yeah, thank you very much again. Okay, welcome from Germany to Hong Kong and the rest of the world, maybe. I will talk about the research data management at the University of Hamburg today. And there is a short introduction to show you a little bit of the surrounding of our university. Then the services of our RDM-Center. I think this is a more or less special construction also in Germany. Then research data and ethics. And at the end of my talk, I will give you a little bit of overview of the practice in RDM and some open questions, which will hopefully foster the discussion. This is Germany, you see on the right side, and the little red area is the free and Hanseatic city of Hamburg. It's one of 16 federal in Germany, and it is the second largest city after Berlin in Germany, with a population of 1.9 million people. I think it's not very large in if you compare it with Hong Kong or something, other large cities in the world. Nevertheless, part of Germany, I think it's the third largest port in Europe. Our university has the aim innovating and cooperating for a sustainable future in a digital age. You see digital and sustainable in this claim. And for our university, it's very important that we think also about the sustainability of all our services. Sustainability is not only meant in this field of environment or to save some energy or something, and services who should be sustainable, available for a long time. So also our data, for example, should be available for a long time, and this is then a kind of sustainable future, and also in the digital age. The university is relatively young. It's founded in 1919, and it was the first democratic foundation of a German university. 100 years later, we are as a University of Excellence. This is a special research program in Germany, and with 4 clusters of excellence. There are mainly in the area of physics, it's advanced imaging of matter, climate change and society, and quantum universe. This is more or less physics and climate research. And also in the humanities, this is understanding written artifacts. This cluster is dealing with study of manuscript. This is really especially meant not only in Europe, it's meant for the whole world, especially also Asia. I have a colleague who has done for years Chinese studies, and this is the, let's say the point where it's all started. Our university has 74 BA and 94 MA programs. We have more than 40,000 students, 50% female and 14% from international countries. We have more than 700 professors and 6,000 research associates. The money is maybe not enough, but nevertheless, we are funded by the state with 600 million per year, and we have additional external funding from funding agencies with about 300 million. And we have 8 faculties. And as you can see on this map on the right side, spread over the whole city. So we have not one central building, we have a central campus really in the heart of the city. But our institutes are spread over the whole area of the city. This is also an advantage for us. If we have to talk to colleagues and so on, it's often necessary to drive to the whole city. And yeah, it's not so easy at the end. Our center is a central operational unit. It's assigned to the Vice President of Research, so it's assigned very high to the presidency. We were founded 2017, and this was in close connection to the Excellence Initiative, because the funding institutions demand on research data management in this area. They said, you will never get cluster of excellence if you don't have a professional service for research data. And this was one of the situations, maybe in lifetime, to found something like a center like this. Currently we are 9 full-time equivalents, or 9 persons. And on the right side, you see our building. We are on the first floor in this building. It's very old. It's more than 100 years old. And it's very interesting. It's a so maybe sustainable in this way, and also it's about caring. We are not caring not people, we are caring data. Our services at a glance, I will give you just a short overview, we'll come to details later. We have, it's clear, consulting, training, and information. We have a research data repository. We are also responsible for the research information system of the university. We're providing digital object identifier. We have a tool, also a consulting for data management plans. We have services for curation of applications, mostly web applications, and a so-called URIS database toolbox. One of my colleagues is responsible for the Fundes scientific collection portal. From last year on, we are also support for the University of Hamburg. And from this year on, we have electronic laboratory notebooks. And we are also responsible for open access and open science at the university. You see, it's a lot of services for the whole university, and it's all done with 9 people. I think it's not so bad. So our claim is we bundle infrastructures, competences, and tasks in order to offer sustainable services. All our options are unlimited, so it's not time-limited positions. We are not a project or something like this, like often seen in other institutions. We are permanent financed, and I think this is the main thing in this area of sustainability. Why we have a special dedicated center and why we are not part of the library? Because we have in Hamburg, we have a special situation. We are 2 independent organizations. We have on the one side the University of Hamburg with faculty libraries. They are relatively small and also very special libraries. And on the other side, we have the state and university library. And this is really a own organization with their own governance. So it's not so easy to bring services to both sides. And in 2016-17, there was decided that we should have a center for research data management, which is very close to the research. So where the research happens at the end, and this is in the university. And so we were happy to build up a dedicated center for this. this is the only reason, I think. It's not really the reason why our state and university library may be not able to do this. It's just an organizational reason. But now, from this year on, we have a large reconstruction change project to bring this university library and their services and the university and their services closer together. So we will, at the end, hopefully in 1 or 2 years, we will have a virtual library or a virtual information system service provider, something like this. To give you a little bit an overview over the situation in Europe, we have let's say a network, something like this. One player is the NFDI, the National Research Data Infrastructure. This is a project. It runs more than, I think, 10 years at the end. And there are consortia in it. They are very specific for their research field. So you have a consortia, for example, for physics, one for chemistry, one for literature, and so on. And they think about research data in their specific fields with the specific demands on research data. But at the end, the name is infrastructure, but they don't have infrastructure really. And this is where these small dots come in. These are service providers, and the service providers are university research data centers and some of core facilities, specialized data centers, for example. Then we have the European Open Science Cloud. It's the dark blue area. And this is also more a virtual construction. It's also has service providers because you need an institution in the background. And they have close connections with the NFDI. And you have domain-specific repositories all over the world. There are some for astronomy, for example, or for chemistry, for DNA, for medicine, and so on. And they are well known, and I think this is the best where you can store your data if you are working in this area. But if not, maybe everything is backed up by the EOSC, sorry, and maybe or by the NFDI, or at the end by a local institution. And this is where for example, our university comes in. We are one of these service providers, maybe for the other. So there's an interconnection between everything. And if there's a researcher, for example, from our university, and he has the possibility to save his data in a domain-specific repository, it's fine. And if he has not the chance to save his data there, he can save his data in our repository. At the end, it's important that he saves his data and maybe publishes data. So I will now come to the services of our center, and I will not go to every service in very deep, but the main services I will explain a little bit. And the beginning is, what do we, at the end, research data management? Hopefully it's obvious for you also, but it's an important topic in grant applications, especially in Europe. Funders have these expectations, and there is no application without a chapter about research data management. Most journals request DOI, or at least a citation for research data. They have their own services in place, and very often they will have money for this. So maybe it's not a wise idea to give Elsevier or some of these big players much more money to store their research data there. Then especially in the natural sciences, data publications are very common. In the humanities and other areas, they are not very common, but I think it's a growing area of publication now. And also in the humanities, people see that maybe it's interesting if they are really working with data, not only with books or something like this. We have this, it's not a law, but it's the idea behind good scientific practice to have reproducible results. And they are only possible if you have your data by hand. And if people ask, can I have your data, you can give it to them. And it's not a wise idea to have your research data on a USB stick or something. I think this is not very sustainable at the end. Then research data are very expensive. If you have large experiments, for example, or you have large field work or something like this, it's very expensive to get your research data. And so it must be stored somewhere where we can reuse it. And at the end, everything we do and also our other services are a foundation for open science. This is not necessary that everything should be open at the end. So it may be no problem that you have data which will be not open data at the end, but you have to tell that you have this data and people can ask about this. I think this is very important. And openness not only is 100% open, openness starts with telling about what you do have in your, maybe in your shelf. You may ask, what is research data? We say everything what is digital data in this area and materials used in research. It's not only numerical data, we have also audio, video, text, surveys, images, whatever you can think about, also algorithms or really software, especially 3D data are very complicated. So everything on digital data is for us is research data. And we also accept all file types and file formats from kilobytes to petabytes. It's very important because we have 8 faculties from all science areas, and it's very important that we accept that people have a huge amount of data, especially in the physics, for example, and that also it's important for people if they have only an Excel file, which is very small, but it could be very crucial for them. So, but there are also some services we don't do really. We do not offer disk space or compute time for daily work. This is part of our computer center. We don't know, we do not specific offers for software development. So you cannot ask, can you develop a database for me or something like this? There are some rare exceptions, but normally we don't do this. And we do not preservation services for physical objects. I think this is a complete other area. Maybe you know this data life cycle. And we fulfill all services around this life cycle. We start with the application services. So if you want to write a research application, we will support you. Then you can set up a data management plan, have services, electronic lab books. Then for this area of save your work data, describing your data, data exchange. And very important, we give courses, training courses for PhD students especially in larger projects. It's very important. And at the end, maybe you have a web application from your data. We will maintain this on a long time. In brackets here, keys for encrypted data. I understand why people encrypt their data, but I'm not really a fan of encrypted data because it's always a problem. If you lose the key, then you have lost everything, or if the encryption software doesn't work in 10 years or 20 years. This has happened already, and we have done problems. So I'm not really a fan of encrypted data. We enter that data base host access data as a data trustee. This is also a very important task if you have data which will not be open available and people are gone maybe in 10 years. And then if people are interested in this data, you have this to decide how to get access to this data. And at the end, we have our research data repository, which is an archive for data and keep it ready for 10 years and even more. So we fulfill the whole data lifecycle with our services. And at the end, people have to do this. Yeah, okay, they have to ask. It's not obligation for them to come to us, but I think more and more people will use our services. People always ask, is there a best practice? Yeah, maybe. My short answer is do it at all. How you do it may be the second question, but do it at all. Think about it. Use standards, open licenses, persistent identifiers, respect the law if you have delicate data. Then make your data fair. This means findable, accessible, interoperable, and reusable. And the F, the first, findable, is the most important, because if you have accessible, interoperable, reusable data, it's fine, but if no one can find them, it's senseless. So findable is more important than the other ones. Then it's not necessary to archive everything. You should only archive your final data and products at the end of your project or of a project phase or along with the publication. As I said in the beginning, research data should be stored where it makes sense from a scientific point of view and where the data is then available for long term. So if you have a community-specific repository, if there is one and it's a good one, then use it. If not, then you can use the repository of the local institution. In Hamburg, it's our repository. At your university, it's your repository. And I think it's also very important, as open as possible and as closed as necessary. Especially data from the humanities have several disadvantages in openness, because sometimes they have copyright issues or you have issues with data protection. Europe is very, very sensitive about data protection, and this is a problem at the end if you have some names in it, or even if you can reconstruct which person has said something, it's a problem. So you have to be careful. And then it's possible to say, okay, I say I have this data, but it's not open available for everyone. But also there are situations where you don't have to publish your data. And I think it's easy if data has been published elsewhere, then just cite it. If a researcher from our university uses, for example, a data set from your university, it's not necessary to store it again and again and again. He can cite it. When there are privacy issues, the data are confidential. In some cases, you have these problems, a special need for protection, or if the data could pose a danger. For example, if you have research in this area of viruses, for example, then maybe your research could pose a danger for the world. Then maybe it's not wise to store your newest data about the newest viruses as open data. Also, if the origin of your data is unclear or illegal or something like this, you should not use such data anyway. But this is the this is the field for ethics at the end, and I will come to this later. So the first really service is our research data repository. We use as a software in the background in Meunier RDM. It's a development in close cooperation with CERN in Switzerland. And they developed also .org, and this is a service project. And in the beginning of our center, we asked them if we can have a copy of Zenodo, of the software, and they said, no, it's not really possible because it's a service, it's not a software to download. And we have a lot of talks with them, and then at the end they said, okay, we give them a try, they give us a copy, and now we have really a copy of the software of Zenodo. It's in Meunier, and then we started a project together with, I think, more than 15 other institutions from all over the world to develop Meunier RDM. And this is just a few months ago, there's a brand new version out, and it's really good software for research data repository. In the background, we have a S3 object storage with several petabytes and multiple locations for backup. The backup locations are all in Hamburg. This is a problem of governance in Germany because it's not so easy to bring a backup server, for example, up in Bavaria, something else. And but at the end, this is a security question. As a metadata scheme, we use DataSite. It's very general. It's not very specialized. And at the beginning, people are asking always for specialized fields for their area of research. That is not really possible. And at the end, if we fulfill all these requirements, we will have 1,000 or more data fields, and it's not very sensible for the metadata. And now it works very well. People say it's no problem. There's a large field for descriptions, and they can use this for their special fields. The metadata are always open to the public. This is the first step, as I told, the F in FAIR. You find the data. The data itself attached to this metadata entry is maybe closed, open on request, embargoed, or completely open. You can decide this. If you publish your data, you will get a DOI. I think it's clear. We have a versioning and also MD5 checksum so that people can check is this really the data they want. We have communities. You know, Zenodo, there are also communities in it. It's like a virtual file directory, something like this. And it's very good for research projects if they want to collect everything they have in their project and then everything you have in one community. Our storage is for at least 10 years. This is our guarantee, and this is normally what our research did. And I think it's not a problem to store everything longer, but it's hard to guarantee this. We have no limitations on file types or file size because, size maybe if there are people from the physics, they have no problems to produce data in terabytes in less than a second. So there may be the limitation, but it's not the normal file size. So at the end, we have no limitations. And it's a self-service. We have no charges for members of our university, and it's not necessary to ask anyone. If you have an identifier and you can log into our repository, you can upload something and you can publish it. And we don't check anything because this is not really possible for us to check if this is the right data. Are there errors in it or something like this? If we have, we overlook what comes in, and if there are some problems, if we face some problems, we will contact the people, and normally it's no problem to correct anything. But we have the problem that, especially in the humanities, and I worked, as Benjamin said, very years in the humanities, they have all the problem. They want to come up with a web-based database. It's a web page with maybe a database in the background. Normally, they don't need really a database because they don't have so much data, but they are always talking about database. This is very modern, still very modern. But these databases have the problem that after 3 years, the normal project time, there's service to this database, and some months, even years ago, they were dying. And together with the Cluster of Excellence Understanding Written Artifacts, we have developed a concept databasing on demand. So this means that we store the data in our repository and have a slightly construct of JavaScript and HTML to present the data like in a database. The images show on the left side a table, very good search functionalities and sort functionalities. It really looks like a database, but it isn't. It's just a table-based data in the background stored in our repository, and the rest is JavaScript, and it's only built in the moment if you call this data. On the right side, you see we can combine it also with graphic interpretation. This may be interesting for everything from outside the humanities. And it could be named like living documents. And very important, you can cite these versions of databases. Normally you have a database and people change every day something, and it's very hard to cite a database or entry in this database. But here, you have stored it in our repository, you have a DOI, it's not possible to change your data in the background, and you can, if you have a new version, it's a new version. It's a little bit confusing for some people, but if you explain, it's like the good old book. You have the first edition, and then have maybe 2 years later a second edition, and the first edition is still available in the library. So it's no problem, hopefully. This is very interesting because we saved a lot of local databases for this. In this project, for example, it's about 10 databases we didn't build up. So I think it's very interesting for the next years. Nevertheless, in some projects, you need really a database, and what means more than databasing on demand. And therefore, we have a database construction kit. I call it always a construction kit because it's not a database itself. It's called Jurist. It's a development of the humanities faculty in the University of Sydney some years ago. And the reason is we don't want a zoo of applications with missing documentations, missing responsible persons, growing update and security issues, and shut down after the project sometime. So we introduced these Euros. It's very easy to use. It's one system with databases, so the administration in the background is very, very easy. But it has nevertheless some disadvantages. It's a very small open source community. It's hard to keep it ready for the future. So we are thinking sometime, if there could be something new, if we have to develop something new or to redesign the whole product. But this is not so easy because Jurist is developed over years. And if you have ever thought about to redesign a complete software construction, then you know how hard this is. But our idea is to bring it up in the future. Then maybe this is very interesting. At most universities have collections, research collections or scientific collections, and also all universities has a lot of research collections, and they are not available for the public at the end. And we want to provide a digital insight into the scientific collections of our university, and they're very close to the university, the Leibniz Institute for the Analysis of Biodiversity Change. They have a lot of natural sciences collections, and also the State and University Library. So we have a broad range from natural sciences to humanities, and if possible, we have some images, we have some data, not every type of data, but some data, and we have a search function, and also since last year we have experiments with AI approach on image search. We have a cooperation here with a Hub of Computing and Data Science, HTDS. center which supports research projects in using AI and data science in their research. So it's not meant, Fundus is not meant for the research, it's more or less meant for the public. So it's a kind of openness for us to show how interesting our collections are, impressing collectors. Maybe they will create some ideas. And the people from the collections are very interested to give their data to us. It's a slight of process to bring them to life, but it's not very complicated. And the whole application is developed by us in-house. So there we have no problem to with software at the end. Yeah, our center is also responsible for the research information system. This is a database. Hopefully you know what a research information system is. It collects information on research at an institution. It means citations of publications, project information, equipment, whatever you think, activities, and they are interlinked. In the background, we use the well-known pure software from Elsevier, and for the public, we have set up a very special portal. We don't use the pure portal from Elsevier because it's expensive, and we have very strict demands on our visual corporate designs. Yeah, that's the right word, on the corporate design. So we have to bring up a corporate design and not with the corporate design from Elsevier. So we programmed our own one. And we have the research portal. This is the central entry. We have include boxes. They are integrated in our web content management system so that people can, for example, have publication lists, project lists, activities lists on their personal websites, for example, as you can see on the image on the right. The research information system is also used for reports and for indicators for the university. And we are not collecting 100% because this is, maybe it's a very hard job, but we are in between, I think, about 70 to 80%. And this is not so bad. Most universities don't have 100% collected their research information. So this is a part of open science. If you talk about what you have, for example, for research projects, normally you don't have such information. So we have some other services, they are more or less smaller, so I will just name them. We have the Research Data Management Organizer. It's an online tool developed some years ago in Germany for writing data management plans. There are the requirements of our European or German funders implemented, so it's very easy to write a data management plan, for example, for application for the national research funding. We provide digital object identifier. I think this is no problem at the end. It's just a very easy service. We are responsible for open science. We support open access. We have open access funding here. I think also, as all over the world, we don't have enough money to pay everything because these APCs are very rising up in the last years, and we don't have enough money for them, but we give them a try. In the last years, we had a very large project here in Hamburg, Hamburg Open Science. It was a joint project from all universities and scientific institutions in Hamburg to foster open science, and also some of our services are born in this project. From last year on, we have CUHK. It's a chatbot for students and members of the university. It's free in use. We don't run our own large language model. We use the services of OpenAI at the end, but we have a special access for this, and this is compliant to EU data protection regulations. I think this is very important for us. So OpenAI doesn't know who asked, for example. They only know there's a question from the university, but anything else they don't know. And the university pays for this for all users. We have, it's running in April, it's running 1 year. We have more than 1 million requests or prompts and more than 12,000 users regularly. So not all students use it, but a lot of them, I think. Yeah, we give training and support. I think this is clear. We have also conferences. In 2019, we host the Open Repositories International Conference for the first time in Germany. There are 500 participants, for example. We have the electronic lab book. It's open source software from Europe, eLab FDV. And in close connection with our chemistry department, we have another one. It's also open source, and it's also a development from Europe. And we have an archive for switched off websites and applications. This is also very important because every research project has a website, and after the project, normally no one cares about it, but there are some very important information on it, and we save them then. And the oldest from now is from 2004, so 21 years. I think it's not so bad. So this was more or less our services, and I will now talk about research data and ethics. As you have heard, I'm member in the Humanities Ethics Committee at the Cluster of Understanding Written Artifacts. No, the Humanities Ethics Committee, it's from the faculty, sorry, and I'm also member in the Ethics Working Group in the Cluster of Excellence. And our claim is misuse of research data can cause significant harm to people in research. This is very important for people working in the humanities or medicine area with people or with material from the culture. And normally we try to follow the FAIR principles. You have heard about this, and the CARE principles. And the CARE principles are more or less the same, but they incorporate ingenious people who should, for example, benefit from the use of the data. It's not a good idea to say, I want to do research maybe in Africa, somewhere in the jungle, and I want to visit people. I ask them something, I take photographs, I collect material, cultural artifacts or whatever, and then I will be well known in the world, and the people there will have nothing from this, from my research. And this should never happen. So it's very important for us that people in these areas have a benefit from this. They are informed what will happen with their data, maybe with the photographs, with the artifacts, and so on. And you have you need to take care about the artifacts, for example. And it's very important that you watch out if you are working in areas with political problems, for example. It may be very dangerous for some people if you do research in some areas and bring up some results. So this is an area of care. A publication for this and some points out of this. I will not read the whole text. So, but it shows what you have to do if you begin your research. In the beginning, you have to plan. I think it's obvious. Maybe you need some consent forms or specific contracts or whatever else, yeah. And you have to plan this. This maybe is the data management plan, for example. Then when you go out and collect data, maybe you take photographs, you have measurements and so on, you should be careful and avoid any risk of damage. And also very crucial, you have to document everything. Field and also in the laboratory. You have to use digital file formats which are common. A scheme for names, for example, directories, and so on. It should not be very crowded in on your data storage, for example. If you are in the field, you should store everything twice on different storage facilities. It's very important. So we have people, they are doing research for weeks, and afterwards everything was done because they did have only one copy, and this one copy was damaged or lost. Then you need an evaluation at the end, a processing, for example, or very important, geolocalization. If you use a smartphone today or even a modern camera, you have normally you have automatically the geo coordinates in your photograph, and maybe this is really dangerous to people if you have this, or also for cultural objects, for example. If people see this is a very nice cultural object and you have the geo coordinates, then maybe the object is gone the next day. So you should delete this information, for example. And so you need to review process. Also images with buildings, signs, and persons may be very dangerous to people or to, even for states, for example, and then you have to avoid something like this. Also, research data from illegally traded objects or data with unclear provenance should not be used. I think this is very, very important. Some people think no problem to have this data, and they say, yeah, but I can't do my research if I can't use this data. But if this, for example, is illegally traded or you don't know where your data comes from, you should not use it. Especially in this cluster of excellence, understanding written artifacts, we are doing research on written artifacts, and we are looking at photos of them, but maybe if they are three-dimensional, we have three-dimensional scans from them, and we have also material analyzers in some cases. And all this data can lead to very deep fakes. If you know everything about the object and you publish this data, maybe people can fake a new object. Also, if you have images, it's very easy to manipulate colors, sizes, and other parameters. So you have to think about, is this real, what you see? And even if yes, you have to think about what will happen with my data and my images. Maybe they are subject to forgery. Very common misunderstanding, especially in Germany, is my data. And we say, yes, you have the right to use the data first, but normally the research is financed by public money. So the collected data is not your personal property. Some people think about this. And at the end of the project, you have to share your data as widely as possible. Because normally we have a contract between the university and the funding agency or institution, and not between single person and the funding institution. This is always, worth a discussion, and we have I would say in 7 of 10 projects we have this discussion. It's very interesting. If you are interested, we have the whole ethic guide. This is especially for this project, but I think it's easy to use for other projects. It's free available. So I'm coming to my last 2 slides. Just an overview to RDM in practice and some open questions. In practice, imagine a collaborative research center. Maybe excellence. We have about 50 PIs, 100 PhD students, and additional staff from different research fields and traditions, from the humanities, from the natural sciences, in some cases also from medicine. We have different types and amounts of data, and we have just a checklist. So the first is, in such a project, you should have a responsible person for research data management. There must be a person who says, okay, I'm in charge for this. It's not necessarily a special finance person, but there must be a person who is in charge. Then at the beginning of the project, or if new people come in, you have you need an introduction to the rules and regulations of the CRC, including RDM and ethics, to make it clear what is the idea of your center and what are the do's and don'ts. Then we have normally for all PhD students and for RDM training. It's regularly, it's 1 day, and they have to write a data management plan for their research projects. These are normally collected by this responsible person from the CRC and then slightly checked by this person, and the researcher has to renew it once a year. So that at the end we have a current data management plan, and then we can take this plan at the end of a PhD or a project or a contract and look at this and say, where's all your data? Is it available? Is it well documented? And so on. And the CRC normally awaits a data list, like a publication list. It's normal to give a publication list to the administration, and we also want to have a data. So maybe this citation, my data are stored there, my data are stored there. Maybe you give along a hard disk if necessary. You can say, these are my data on this hard disk, and yeah, then you have to see to deal with them. The Center for the Study of Manuscript Cultures is a good example. In this center, this is the cluster of excellence. It's just another name for this, because we have behind the cluster, there is a center at the university. We collect everything in the community in our research data repository, also secondary material, posters, reports, and other great publications. And it's very easy then to give this to the funding institution back if you need to write a report, for example. Yeah, some open questions. We didn't solve anything. I think it's impossible, and maybe you have some ideas, or maybe you have the same problems. We have the problem deleting data on the long term. In paper-based archives, they have concepts to have a revision in this and to throw away anything or something. This is no problem, but for digital data, we don't have a concept like this. And maybe it's possible to store everything forever, but maybe it's not, we don't know. Then we have very special data. Just one example, virtual reality with VR glasses. This is very special because you have the data and you need some hardware for this. And also data formats, very special data formats from instruments. Yeah, it's very hard. We can store it, but we can't guarantee that you can use it in some years. And normally we do not do a data conversion. We have a bitstream preservation. We leave it like it is, like in a real archive. They don't have a conversion from paper to some other paper or something like this. Then we have the problem how to deal with the software obsolescence if we have very special formats, for example. We have still problems with geographically distributed storage. This is a question of disaster recovery. This may be very special in Germany because we can, not so easy to buy something, for example, from Amazon or Google. We have to store everything in Germany, and it's not so easy to have it in the other federal states. And maybe this is really new, but very interesting. How can we provide research data for AI? So it's the end, and I'm happy. Maybe if you have some questions. Thank you very much.
Thank you very much, Dr. Thiemann, for your insightful sharing on the services your center provides. I think you've given us a very wide range of RDM services and practices your center upholds and supports. I think some of the services even branch out into digital humanities and digital scholarship, which is very fascinating to me. Thank you again for the very insightful and informative sharing. And now we're opening the room to everyone, anyone who has any questions. So is there any questions coming from the audience? You may type your questions in the chat box or unmute yourself to ask your questions or give any comments you might have after hearing this fantastic keynote lecture. Yeah, Ben, please.
Very much for your really insightful presentation. My question was, it touches on the last open question that you asked us as an audience about how do we expose research data to AI tools? But it's the other way around. So my question is, how do you, in the center, in the centers that you work in, manage data produced by AI tools and then ingurgitate that into research data sets? Because of course it could be valid data, it could be invalid data. It's very hard to tell. And I wonder how you manage that bit of the data cycle.
Yeah, thank you very much. It's very interesting. Until now, maybe in 10 minutes we have one. Until now, we don't have this problem. But for sure it will come. Yeah, people are working with AI in any kind, and they will produce some results with this, and they want to store this. Okay, but at the end, people have to remember good scientific practice. They have to describe what they have done. Yeah, we have used maybe OpenAI. We have asked this question, this result, and they have to document it well. And then the result is the result. It's more or less the same if you have a measurement from an instrument. This could also be wrong if you have a wrong calibration, for example. Yeah. So I think it's the same thing, but you are right, they have to document it, and maybe we have to, maybe we have to have an eye on that they really document it, that they're not right, yeah, this data comes from somewhere. I think this is the main problem.
So I have a, well, actually there's a question in the chat box says, do researchers readily want to share the data? Do they think that open data is the default?
Yeah, open data should be the default, but I think I have explained that it's not possible to everyone. If you are working in the psychology area, for example, it's maybe there are some data could be open, but if you, for example, have very personal data, it's not possible to spread it open. But this is not really a problem. You can anyway store it in our repository, for example. You have this entry, you give people the information. I have data from psychology experiments, for example, and if you are interested, you can contact me. I think this is also a kind of openness in this area.
That's right. Thanks for your response. The next question is from Mr. Alwin Law. Thanks for inspiring presentation, Dr. Thiemann. You mentioned that findable is the most important element in the FAIR principle. In what ways would you advise us to increase the findability beyond our own institution only? For example, are registering our data repository onto platforms like R3 Data or Google Scholars are good choices?
Yeah, we are, yeah, thank you very much for this question. I didn't mention this, but we are listed on re3 data, for example. We also experimented with, not with Google Scholar, but with Google Data. But this is a little bit a weird service, I think. At the and they listed all our data sets, and then it become more or less worse. And sometimes they list our data sets, sometimes not. We are trying to have to be present in all these search areas, let's say in Google and also in maybe in some scientific search machines. But it's very hard because, for example, in Google, you will find on 3,600 because no one clicks on our data sets. Yeah, this is the problem at all. And yeah, people can increase it a little bit if they use keywords, very common keywords, for example, and not very, very special keywords if they use them. And also the DUI registration as a kind of findability. But at the end, yeah, as I entered something in your repository, I published it, and then I Googled it, and I didn't find it. Okay, this is very hard to fulfill, that you can find it after a few seconds, and also that you are on top one if you really Google it, because in most cases there are a lot of material in the world which is on top of all this. So it's possible, and we are working on this, but maybe it's not findability like this, like Amazon or something like this. I think it's obvious. In most cases, I think this is the more interesting way. In most cases, people read scientific publications, journal papers, for example. And at the end of a journal paper, you have citations. And then, if you then have there a citation for your data, that will come over this way. I think this is maybe the best way to spread that you have some data.
Thank you, Dr. Thiemann, for your feedback. I actually have two quick questions here. So I think one of the first slides you mentioned regarding the RDM services your center provides, you mentioned about the application support. So I'm just curious about what kind of application. Is it web applications? You also mentioned that on the slide. So that's my first question. The second question is about your actual research data repository. I think you mentioned that you actually accept all file formats, which is very interesting to me because we do have a list of file formats that we do not accept in our repository. So I'm just wondering, how do you handle those executable files? So would they ever cause any concerns to you, or you just accept basically all file formats to the repository? Thank you.
Yeah, the first part of the question, the applications are mainly web applications, not local running software, for example, which are only running on a computer. Some years ago, people come really with CDs or DVDs and say, my software is on this CD and you have to prepare it. Okay, I think this is very hard to fulfill. At the end, these are mainly web applications. And yeah, a research project, you have some student assistants, for example, and the student assistant use some software from the internet and they build up something. It looks very nice, but it's not very documented and it has no standards and so on. And then it's very hard to care about this. So in most cases, if we have something like this, we can in a static web application, let's say, it works, everything is there, but it's not really possible to work on it, but it's then archived and we will keep it for the next years. So we didn't lost anything in the last years. Sometimes some function may not work, but yeah, it's not really a problem until now.
Great.
I did forget the second question. part of the question. It was, can you help me?
Yeah, sure. Yeah. So thanks. The second question was
Sorry.
about the file formats being accepted in
Yeah.
the repository. Yeah.
Yeah, sorry.
No worries. Thank you.
Yeah, nevertheless, we have a list of file formats which are so-called good file formats. Yeah, okay. Yeah, maybe this is the same list you say, okay, some file formats are very fine. And also executable files, and they are only stored as a data blob. It's not possible to run them. So it's if you have let's say an exe file, for example, it's just an exe file, but it's not possible to start it in the repository. It's just a data blob at the end. Behind this is it's very hard. People have weird ideas. For example, if you say for images, the TIFF file format is the best you can have, then it's okay. But then people coming with JPEGs in original, so they have only a JPEG file format, for example, from their, let's say, from their smartphone, yeah, they have only a JPEG. Then they started to convert JPEGs to TIFF. The best you can have, but this is not the idea. If you have a TIFF, then you should keep the TIFF, and maybe you have additionally a JPEG for this for handy reasons, but you should not convert from the worse format to maybe a better format, because this is not a good idea. So it's really, for us, it's really problematic to say this is a fine file format and this not. So we accept everything. Yes, we have some ideas what could be a good one, and that's why we say common file formats. So you should not use file formats from which you are the only person in the world who will use it. I think this is not a good idea. But we don't see any problems in this area because most people really use common file formats for their area, for very special file formats, and use it. Yeah, that's not a problem.
Right. Yeah, I see your whole repository embraces the openness concept. So it feels very open to me.
Open in all directions.
Yes, that's right. So maybe Dr. Thiemann, would you like to share one of the opening discussion questions on the second but last slide?
Yeah. This one?
Yeah, thank you. Any questions coming from the audience?
Maybe I can. This is what I explained to the last questions. We did only bitstream preservation. Yeah, we take the bitstream as it is. We do any conversion. Also in the future, we are not planning any conversion. Maybe in the world, I don't know, but in Germany, it's very common that people say, but you have to convert it maybe every 5 years from one format to the other format. We think this is very risky, and you can do it if you only have, for example, a PDF file. Maybe it's possible to convert it in 10 years in another format, but it's very risky at the end. And my idea behind it is imagine nowadays there is a person taking photographs of people on the street, and the research is what kind of trousers do people wear? Yeah, and he writes a PhD about wearings on the street in the 20th century or something like this. So all these images are very fine, and you have maybe, as expected, most people wear blue jeans, and the color is blue. So, and then these images are stored in, let's say, in our repository, and in 20 years we have a conversion from JPEG to a new file format. And there was something wrong. And because of data, people don't look at this, and they even don't know what happens in the last years. So they have an automatic process, and at the end, all the blue genes are slightly red or something like this. Maybe it's very extreme, but they are not, at the end, they are not blue. Everything is stored again, and then 50 years later on, there's a new PhD student, and he has the task to compare it, what people will wear in the year 2150 compared to what do people wear in the year 2025. And he will discuss this with maybe red trousers. Everyone wears red trousers in year 25. Why? Because there was a conversion error in it. So I think this is very, very dangerous to convert anything, because it's not possible to have this conversion without errors, and it's not possible because of the large amount of data to look at this results. You can do it, yeah, maybe every 1,000 file you can look at and so on, but it's a very hard job. So I'm not sure if it's a really good idea to have this data conversion. And normally in paper-based archives or film archives, they don't do it at all. They maybe they make a copy for security reasons, yes, but they leave the originals untouched.
Right. That sounds very fair. Well, thank you so much again for sharing all this information with us. Given the time, I think we're going to end the session now. But thank you very much to the Thiemann for your insightful sharing on the research and the management efforts and initiatives at the University of Hamburg. I really appreciate all the information you've shared with us. I think the topic of open data, sharing data openly, upholding the FAIR principles, and data ethics are indeed growing trends in the RDM field. So your presentation today has broadened our understanding of RDM development related topics. So thank you so much for spending your early morning delivering this fantastic keynote lecture to us. So I'd also like to extend my gratitude to everyone who joined us today for engaging in this keynote lecture. So we hope that you have learned something new and interesting today. And we hope that you will be able to attend the other events we have planned for the Data Excellence Week 2025. We'll have 2 more events happening later this week, one on Thursday and one on Friday. So we'll provide the registration link in the chat box later. And we hope we will see some of you at the remaining events in the Data Excellence Week 2025, either in person or online. Thank you very much again, everyone, and have a wonderful day or evening.